Welcome to today's class. Today we are going to learn mostly about the derivation, and here is the inverse function. The function fs is equals to tan inverse x. To solve this problem, what we have to do, we have to consider the value of fx is equals to, let's actually consider, instead of fx, let's consider y is equals to tan inverse x. Now we could write down x is equals to tan of y. Now the angle is actually y. So if we now derivate dx by dy in both sides, so d of y, tan of y. Why we have done this? Because the angle or the variable here is y, that's why we have to derivative with respect to y. And by the rules of derivation, tan of x or tan of y, we could write down sec square of y. So dx by dy is equals to, here the main function was actually y is equals to tan inverse x, and the variable is actually x. So what we have to calculate from the question, that is actually dy by dx, because the variable here is dx by dy. Now if we inverse this equation, so we could write down dy over dx is equals to, we could write down 1 over sec square y, right? Now we could write down dy by dx. Of course this is the final answer. So what we can write down, we can write down 1 plus, actually this will be tan square of y. Why? We can write down a side note here, that sec square theta minus tan square theta is equals to 1 from trigonometry anyways. And of course here need to write down 1 here. Dy over dx is equals to 1, and the value of tan y is equals to x, so 1 plus x square. So this is the final answer for the function f of x is equals to tan inverse of x. The example of 3 was, the function was y equals to tan inverse x. Now here, instead of x, it is 3 times of x. Let's consider p is equals to 3x, right? Indeed, we could write down y is equals to tan inverse p. Now do the same as the previous example, like dy by dp, because here the variable is p. And what we have to write? We have to write d of dp, and of course tan inverse p, and p is actually 3x. Let's do the another derivation with respect to actually x, because p is not actually p is actually 3x. Indeed here variable is x, so we have to derivate with respect to x. So right now we can write down, let's say p, right? We will change later on. Now we know that if d of dx tan inverse x, we just proved in the previous example, that is 1 plus x square, right? Here actually instead of x, here is p. So what we can write? We can write down 1 plus p square, because here instead of x the variable is p, that's why p square, and d over dx. What is the value of p? That is actually 3x. And we can actually plug in here and plug in here. So let's plug in, instead of p, that is actually 3x whole square, right? So here we have got 1 over 1 plus 9x square, and if we differentiate this part, we have got only 3. So this is the answer.